So let's take a look again at the definition of a limit. So we've looked at it a couple of times. We still haven't formalized it yet, but that's where we're getting to. So we've talked about the fact that as f of x, which is of course our y value, becomes arbitrarily close to some number L, L being the limit, then the limit of f of x as x approaches L or C is L. We've also talked about the concept of delta, which we will talk more about, but delta again is just that distance from C in either direction. So as delta gets, smaller, which is of course what we're going to end up doing is keep creating a smaller delta, then the distance away from our limit is going to get smaller as well. And so we'll talk about epsilon and what that means. So again, we're going to sort of formalize what these two things mean. F of x becomes arbitrarily close to L, and x approaches C. So try to stick with me here because it can get a little complicated with all the Greek symbols and variables, etc. Essentially, what this graph is telling us is that if you give me some epsilon value, epsilon being some distance from L. So notice I'm going epsilon in each direction. And it makes a little neighborhood around L, which is the limit. So here's my limit. This is where I'm trying to get to. And epsilon gives me this neighborhood from here to here. What I'm saying is if you give me that epsilon neighborhood, there's some delta value that makes a delta neighborhood that sort of corresponds to that. So I can see delta here. This would be my little delta neighborhood. This would be my delta value in each direction from C that would give me, that would contain that x value or C value. So here is all of that formalized just a bit more. So here is the formal delta epsilon limit definition. We're going to do lots of practice together, so don't worry. Once you get the hang of it, it's actually pretty straightforward. Our definition says, let f be a function defined on an open interval containing C. So that means it says except possibly at C, which means it's okay if f of C is undefined, because we already talked about the fact that that's okay, because as long as the function is approaching the same value from left and from right, then we're okay. So again, f is a function defined on an open interval containing C, and let L be a real number. L, of course, is going to end up being our limit. The statement, the limit as x approaches C of f of x equals L, which is just our limit definition, means that for each epsilon here, greater than 0, there exists some delta greater than 0 such that if 0 is less than x minus C is less than delta, so again, x being some other value minus C being what we're approaching, then f of x minus L is less than epsilon. So we're saying the distance between x and C is between 0 and delta, and the distance between the corresponding value, the function value, minus the limit is less than epsilon. So if you understood what I just said, go straight to the next part of the video where we actually do some practice. But if you didn't understand, I'm going to try to make it a little more clear. We're saying if 0 is less than x minus C, the absolute value of x minus C is less than delta, means that the positive difference between our point, so whatever point we're choosing, again, I'm just going to make up an arbitrary x. So the distance here between x and C is less than delta. So obviously we're choosing a point closer than whatever our delta neighborhood allows for. So if that is true, then f of x minus L is less than epsilon means that that corresponding f of x value, which means I'm plugging in x, I'm getting out f of x, that value is less than epsilon. So the resulting value will be within epsilon units of the limit L. So let's take a look at how we'll actually use this. So we are given the limit as x approaches 3 of 2x minus 5 is equal to 1. So again, that means, just so we're clear before we get cracking on this, that means our f of x is 2x minus 5, and our limit is 1. And I got that from right here. And c, of course, is 3 because that's what we are approaching. So we're saying find delta, so we're going to calculate delta such that 2x minus 5 minus 1, which of course means f of x minus L, which we talked about, is less than or equal to epsilon, so epsilon is 0.01, whenever 0 is less than absolute value of x minus 3 is less than delta. So we're calculating delta based on that. So how do we do that? Well, we're going to start right here. We're going to take the 2x minus 5 minus 1 is less than 0.01, 1/100th, and let's do the math. Obviously, I'm going to take away those parentheses. I'm going to combine the minus 5 and minus 1 to get minus 6. And look at where I'm trying to get to. I want x minus 3. So I've decided to factor a 2 out of 2x and out of 6, and then divide each side by 2, and I can see that I ended up with the absolute value of x minus 3 is less than 0.005 just by doing the algebra. So what does that mean? That means I've calculated delta to be 0.005. So all of this down here is essentially me explaining that answer. Since 0 is less than x minus 3 is less than delta, choose delta to be 0.005. Because 0 is less than x minus 3 is less than 0.005 implies, essentially I'm doing the math in reverse to make it show that yes, everything works out. Again, this works for only that one epsilon value. Now, what if we don't have that one epsilon value? On our last question, epsilon was given to us. On this question, it's not going to be. So this one, they're saying prove that the limit as x approaches 2 of 3x minus 2 is equal to 4. So we know, again, based on the delta epsilon limit definition, that if I take my function minus my limit, that it's going to be less than epsilon whenever 0 is less than x minus 2 is less than delta. So again, where did x minus 2 come from? 2 from right there. This isn't as easy because my choice for delta is totally going to depend on my choice for epsilon, and they don't tell me what epsilon is. So we have to do some sort of connection. So how do I do that? Instead of using that value that I plugged in last time, which I think was 0.01, 1/100th, now I'm just going to put epsilon in there because I don't have a value. So I'm still going to do the same work. I'm still trying to get to x minus 2. In this case, I still was able to just factor out a value, in this case of 3, and find that x minus 2 is less than epsilon divided by 3. So therefore, delta is epsilon over 3. In this case, I want you to try this one on your own. I want you to find the limit L for the limit as x approaches negative 3 of 2x plus 5 equals L, which this one should be straightforward. You should just be able to plug in that negative 3 to find the limit. Then I want you to use the delta epsilon limit definition to prove that the limit is L. Once you've done that, press play to see how you did. So again, the very, very first thing that you should be doing here is find the limit, because that's the easy part. We know how to find a limit. If it's an easy function like this, just plug in negative 3. So notice I've replaced x with negative 3 because that's just a linear function, y equals 2x plus 5. Plug in the negative 3, find that the value is 1, negative 1, which is my limit. So now it's going to be what I just did on the last couple of examples. I need to prove that the limit is negative 1. So how do I do that? I'm trying to show that for each epsilon greater than 0, there exists a delta greater than 0 such that that function minus that limit is less than epsilon whenever x minus the limit I'm approaching, c, which is minus -3, is less than delta. So I'm starting here, and I'm trying to manipulate that to become x plus 3. So as I can see, I've got my minus -1, which is plus 1. I added 5 and 1 to get 6, factored out that 2. Again, just using epsilon the whole time on the right side. And when I divided each side by 2, I got that x plus 3, absolute value of x plus 3 has to be less than epsilon divided by 2. Therefore, that's delta. So what does this do for us? This tells us that if you give me an epsilon, I can give you a delta, or vice versa. So MA205ers, in your notebook, in your OneNote class notebook within the Teams environment, I have posted a limits worksheet in the collaborative practice section of your OneNote notebook. Take some time to complete the worksheet with your classmates. It's not graded, but it's really good practice. You can complete it on your own and then collaborate. You can collaborate with someone and complete it together, but I do suggest completing it even though it's not graded, and then I will provide feedback to you when it's all done.